Hi children, how are you doing? Today I want to talk to you about trigonometry. But before we get into trigonometry, we need to talk about similarity because trigonometry is based on similarity. Okay? So, how do we say two triangles are similar with each other? Let's find out. Let's take a triangle and let's try to increase its size by 2 times or 200%. We grow the triangle. So if it had a side 2, now the side has become 4, isn't it? We say that this scaled up triangle and the original triangle are similar to each other. Don't get mistaken and think that it only has to be made 200%. It can be made 300% as well. So the first triangle and the second triangle are similar to with each other. The second and third are similar with each other, and the first and third are similar with each other. I hope you have understood this. Now that we have understood what similarity in triangles are, let's try to find out if you know how to identify if two triangles are similar. Let's take this example. How do you find out if these two triangles are similar to each other? They look all different, right? There are 3 rules to our rescue. The first rule is called the AA similarity. What does it say? Let's look at it. AA similarity says that if you have 2 angles in this set of triangles which are equal, and you have another set of 2 angles which are equal between these triangles, in our case there is an angle x which is same, there is an angle y which is same, then through this AA similarity we can say that these 2 triangles are similar to each other. Now let's look at the second rule. This is called the SSS rule. What does this say? This says that you take any 2 sides between the triangles, and if they have to be proportional to each other. So if you have 3 sides and all the 3 sides are proportional to each other, then the set of triangles are said to be similar to each other. So here we have 2 and 4, 4.5 and 9, and 4 and 8. These are the corresponding sides and they all are in proportion to each other. Therefore, through this SSS similarity, we say that these 2 triangles are similar to each other. We have yet another rule that will help us to identify if the 2 triangles are similar or not. That rule is called the SAS rule. Let's look at what SAS rule says. SAS rule talks about an angle which is same in both the triangles. In our case it is x is the same in both the triangles. Then we look at 2 sides that include the angle. Okay, what are included sides? If we have an angle x and we have 2 sides where x is in between them, then we say that these 2 sides are including this angle. So here 2 and 4.5 are the sides that include the angle x, and in the second triangle 4 and 9 are the sides that include the triangle include the angle x. So if these sides are in proportion to each other, so here it is 4 divided by 2 is 2, 9 divided by 4.5 is also 2. If they are in proportion to each other, through this SAS similarity, we can say that these 2 triangles are similar to each other. I hope you have understood this. So we now know how to prove 2 triangles are similar. Alright, so if someone says, hey, these 2 triangles are similar, and what is it that we do with it? What can we infer when 2 triangles are given and someone says they are similar? We have to employ the property of the sides, the corresponding sides of similar triangles are proportional. So that is the inference that we can get. But then how do we identify which are the corresponding sides? Let's learn to do that. So assume that these 2 triangles are stated to be similar. Our triangles are ABC and PQR. How do you identify which of them are corresponding sides? Let's assume that these 2 triangles are similar through a similarity. That means 2 angles between the triangles are going to be equal. Let us identify the angle. So x and x are the equal angles in the given set of triangles. Alright. What are the sides which are opposite these angles, right? So in our set of triangles, we see that A and P are the opposite sides for the given angle x. Let's identify the second angle which is equal between the similar angles. That angle is going to be y. What are the sides which are opposite y? C and R are the sides which are opposite to the angle y. And then we have just the third side, which is anyway, the third angle is anyway going to be equal, and the opposite sides for the third angle happen to be B and Q. So we have identified now that A and P, C and R, and B and Q are the three sets of corresponding sides. So what do we do now? We use the proportionality rule and state that A by P is equal to C by R is equal to B by Q. This in effect will be the inference that we can make when two sets of triangles are stated to be similar. I hope you have followed this. A small clarification needs to be done when we are discussing about similarity. Please pay attention. So we have taken three triangles out here, and if you see triangle 1 and triangle 2, the triangle 2 is double of triangle 1. Okay, so if you see this side is 2, now it has become 4. This side was 3, now it has become 6. So it has become double. If you compare triangle 1 and triangle 3, this is 2, this has become 6, and correspondingly, if this is 3, this has become 9. Okay, and through a similarity, we can say that triangle 1, triangle 2, and triangle 3, all of them are similar. Okay. But the caution that we need to exercise here is when we use the statement, the corresponding sides of similar triangles are in proportion. Okay, we can compare 1 and 2. Okay, and we get 4 divided by 2. That is, I'm comparing this divided by this is 2, and 6 divided by 3 is also 2. So with respect to these two sides, we are getting the scale factor. The scale factor here happens to be 2. And similarly, when we compare 1 and 3, this is 2, it is 6. So 6 divided by 2 will be the same as 9 divided by 3. Okay, and the scale factor here, each of this is 3, which corresponds to the scale factor of 3 between triangles 1 and triangles 3. Okay, so if obviously this proportion 2 will not be equal to 3. Similarly, if you take 4 and 6, these two triangles are similar, but 6 divided by 4 is equal to 9 divided by 6, each of them being equal to 3 by 2, because this is 50 times increased, but that will not be equal to this scale factor or this scale factor, right? Because this scale factor is 1.5. Okay, so instead, if you want to compare all the three triangles, what we should be doing is we should take the ratio of these two sides. For example, this will be 2 divided by 3, this will be 4 divided by 6, this will be 6 divided by 9, and if you look at it, all of them happens to be 2 by 3. So if you want to compare see the proportionality across all the three triangles, instead of looking at the corresponding sides, we take the ratio of any two sides within the triangle and compare it to the corresponding sides of the same two sides of the second triangle and the corresponding sides of the third triangle, in which case you will get the same ratio. I hope this clarifies. Now that we have understood how to infer the proportionality of the sides using similarity when given any two triangles, let's extend this in case of right angle triangles. Okay, so let's take three right angle triangles here, and as you may observe, all the three angles have 90 degrees common between them. That's why they are called right angle triangles, right? But if the triangles are to be similar, right angle triangles are to be similar, what do we need? We need one more angle to be the same. Okay, so let's assume that all the three right angles have 30 degrees as yet another angle which is same between them. So 30, 30, 30. Now what do we need to do? We need to identify the corresponding sides. So let's take the angle 30 and identify the opposite side to that. So those sides happen to be A, D and P. Now let's take angle 90 and identify the sides opposite to that. They become C, F and R. Now that we have identified the corresponding sides, let's apply the proportionality rule. What does it say? The corresponding sides are proportional. So A by C is equal to D by F is equal to P by R. Now in a right angle triangle, there are some nomenclature that we need to be aware of. Okay, so let's take this right angle triangle and see what is the specific nomenclature that we need to use with respect to the sides. Assume that this angle is X. So the side which is opposite to angle X, we call it as the opposite side. But the side opposite to angle 90 is given a special name. It's called hypotenuse. So opposite side and hypotenuse. With this nomenclature in place, we can say that the identified set of ratios is nothing but opposite side by hypotenuse. In trigonometry, they have a special name for this particular ratio, and that name is called sine. So in our given case, sine of x happens to be equal to A by C equal to D by F equal to P by R. Now let's get the third set of corresponding sides into place. They happen to B, E and Q, and then apply the proportionality for the similarity once again. What would that be? It would be B by C equal to E by F equal to Q by R. Now let's get the nomenclature in place for this set. So if you take the right angle triangle, you will see that with respect to X, this is called the adjacent side, and hypotenuse we have already discussed. So the given ratio would be nothing but adjacent side by hypotenuse, and we have a special name for adjacent side by hypotenuse, that is called the cosine of X. And the third set of corresponding sides which are proportional to each other will be A by B equal to D by E equal to P by Q. And if we examine the right angle triangle once again and observe these sides, we will see that these sides are nothing but the ratio of the opposite side divided by the adjacent side. And in trigonometry, once again, there is a special name given to this ratio. This ratio happens to be called tangent of X. Okay, so trigonometry gives you these three standard ratios: sine of X, cosine of X and tan of X, which employ the properties of similarity in order to come up with these definitions. In addition to these three primary ratios, there are three other ratios which can be derived from them. What are they? They are called cosecant X, secant X and cotangent of X, which are nothing but the reciprocals of sine, cos and tangent. Therefore, cosecant X is equal to 1 by sine X, secant X is equal to 1 by cos X, and cotangent of X or cot X is equal to 1 by tangent of X. That completes all the ratios that are available in trigonometry. I hope you have understood this. Thank you so much for watching our videos. Please like and subscribe to our channel. Be sure to share it with your family and friends, and don't forget to visit our website www.cogitarelearning.com, where you have linked to all the videos that we have been recording so far. Thank you once again.